everyone, I'm Nick.
I'm Elena.
I'm Eric.
I'm Garen.
And I'm Ethan. We decided to design an engineering system to harvest helium-3 from the surface of the moon. But before we get into all the nerdy details, here's some background.
So helium-3 is a non-radioactive isotope of helium that can be used in fusion reactions. This means that we can use it as a fuel without having to deal with the nuclear waste produced by current fission reactions.
Sounds great, right? Well, here's the problem. Helium-3 is transported through space by solar winds. However, the Earth's dense atmosphere acts as a barrier, blocking the vast majority of helium-3 from making its way to Earth.
Here's the solution. The atmosphere on the moon is much, much thinner than here on Earth, which means that over billions of years, a large amount of helium-3 has been able to embed into the moon's surface in a way that it couldn't on Earth. So all we have to do is get to the moon and bring it back, right? Simple enough?
Actually, it's really complicated. First of all, we have to figure out how to actually mine the lunar surface. This will require mining machines, a refinement process, storage facilities, and an efficient, dependable source of energy to make it all happen. Additionally, we have to find a way to take everything to the moon and then bring everything back from the moon. Here is a short video illustrating how we could potentially use a space elevator and an orbital transfer vehicle to accomplish this.
Then, we have to find a way to make it safe and reliable for humans to operate. We'll start by building autonomous machines that require very little maintenance so that we can decrease space travel frequency. Next, we have to design a system that will process and refine the raw materials into usable helium-3. This will require a lot of research and development.
Our current plan is to launch by the year 2025. We'll spend the time from now until then designing and testing our system to work on the moon. One of the conceptual designs we are currently working on involves using a system of lunar rovers to extract and transport the regolith, a fancy word for moon dirt, to the refining facilities stationed on the lunar surface.
But most importantly, we need monetary means to fund this project. The cost to build this facility, including the lunar mining equipment, the living facility for the workers, the means to store the helium-3, as well as the transportation from here to the moon, is roughly $6.4 billion.
Additionally, the yearly maintenance cost, including labor, food, and a yearly round trip from here to the moon in order to replenish supplies and collect the helium-3, is roughly $4.5 million. With the current price of helium-3 being what it is, this facility could produce yearly profits upwards of $20 million. We predict that these estimated profits will continue to rise as nuclear fusion technology progresses and the demand for a clean fuel source such as helium-3 grows.
There's a lot of room for research into other uses of helium-3 in cryogenics and the medical field. As the demand for helium-3 rises from various interest groups, so does the profitability of this futuristic endeavor.
So how can you help? You can start by helping us raise the money we need to get this project off the ground. Research into mining helium-3 has already begun, but the greatest thing lacking are the funds to make it happen. Any donation you make will help us to reach our goal of creating a more efficient, non-radioactive, environmentally friendly energy source to give Earth a better and brighter future.